Y'all are so cluster joker. You have to keep me straight with that.
So plasticity can function over a wide range of lengths. Okay.
When you warm up before exercise, you're taking advantage of this type of muscle contraction. Steps. I like to remember it's stair steps. Still 4?
What did you say?
Trep.
Trep.
It's like stair step, but with an extra P and an E.
Trep. Okay.
Some people say trepe. That sounds weird. I don't like it. I say trep. Area of the sarcomere where you will only find myosin. The H zone. That was a quiz question. H zone only has myosin, only has those thick myofilaments. Purple. The humerus fits into what structure? The head of the humerus fits into what structure?
Glenoid cavity?
Glenoid cavity. It's like we just saw that on a practical. Teams.
One.
I like how you flashed it to me, but it still covered the number so I couldn't see it.
Can we answer for other people, or does it just have to be the color?
It has to be the color, but you're allowed to talk to your teammates. That's why it's a team. That way everybody gets a chance to answer. And or that one person can't just sit and green. What is the most common type of bursa? Bunion. Way more people have small shoes than anything else. Team. Yellow. A bump under the knee would be tibial tuberosity. Purple. What type of joint allows you to twiddle your thumbs? Saddle joint. They were up. She had her hand raised and was in the middle of answering. Well, I'm not psychic. Team.
3.
You just gotta raise your hand so I know you want to answer. Red. In smooth muscle, calcium is held in pouch-like enfoldings called what? In smooth muscle, calcium is held in pouch-like openings called what?
Caviola.
Caviola. It's like ravioli, but with calcium. And they make little caves. Green. What kind of fibers will you find myoglobin? What kind of fibers will you find myoglobin?
Slow fibers.
Slow fibers. Gotta have them hands up. Well, we're excited about learning. Huh?
You have to throw your hand up, or can you blurt it out?
Just throw your hand up. Wave it around like you just don't care. No? Okay. Almost good to do. So, myoglobin, type 1 fibers, slow fibers, red muscle fibers. All named for the same thing. Yellow. What is the most stabilizing factor for a synovial joint? The most stabilizing factor for a synovial joint. muscle tone. My football players got to exercise. Sure, they just tackle people, but they don't want to dislocate stuff. Team. Good. The final trigger for skeletal muscle contraction is what? The final trigger for skeletal muscle contraction is what?
Right here. The cross bridges.
No,
Okay, one more time.
no, can't do it. You just answered.
Calcium ions?
What about calcium? It's got some stuff to do.
What was the question?
Final trigger for skeletal muscle contraction.
Concentration of calcium?
No, calcium binds to troponin. So once calcium binds to troponin, troponin will twist and change its shape, which will move myosin from the binding sites, which will allow myosin to grab onto it. So once we have calcium binding to troponin, we can't stop it. Right? It's kind of like once dinner is on the plate, that's what you're eating for dinner. There is no going back. Herbal. These act as anchor points for thin myofilaments in smooth muscle. Dense bodies. So smooth muscle has dense bodies. Our skeletal muscle has Z lines. So we anchor the actin so they don't unravel. Good. The inner layer of the articular capsule is made out of what? The inner layer of the articular capsule is made out of what? Synovial membrane. Hello. The ability to be stretched. No. I can't see you until everybody gets away. Extensibility. So when you extend, you stretch. When you elastic, you recoil. Okay, so extensibility is the ability to be stretched. Elasticity is the ability to regain your shape. Herbal. At anatomical position, all major joints except for the ankles are at full what?
Extension?
They're at full extension. That's where we start all of our movements off of. Green. The only part of the pelvic girdle to articulate with the axial skeleton would be what? No.
Ilium?
The ilium. The ilium is going to touch the sacrum. 2, right?
Yes. When a muscle decreases in size, it is called what? When a muscle decreases in size, it is called what? Atrophy?
Atrophy. You get smaller. Atrophy. It's a nice way to say shrinkage. Green. Most of the synostosis joints in the body usually start out as what type of joint?
Will you say that?
Most of the synostosis joints in the body will start off as what type of joint?
Synostoses?
No.
You said what again? Sorry, go ahead.
Most of the synostosis joints in the body usually start off as what type of joint? Most of the synostosis joints in the body usually start off as what type of joint?
Synarthrotic.
No. That just means can't move.
Oh.
But I want the actual type of joint that becomes a synostosis. It's able to do so because it doesn't move, but I need the specific.
The cartilaginoid joint.
That's a wide category.
A bone confusion.
That's what it is doing. I'm just dancing around the answers.
Right here.
Dancing.
The center.
No, it is now open back to the floor. No.
Random question. Are you asking for like an example of one?
I want the name. This joint becomes a synostosis joint. So most of the body's synostotic joints usually start off as what type of joint? Y'all are giving me the structures of it, but I want the actual name of the joint.
Okay.
No, there's only one of those. I say most.
A fused joint?
Stop that. Fusion is what it's doing.
Are you asking like what
Over
bone?
here.
No.
A plane joint?
No. At least team 3 who hasn't fallen into the trap for the second time. Usually it's a very
Can you repeat the question?
serious trap. Most of your synostosis joints start out as this type of joint.
One more time. Last time.
Liar. Most of your synostosis joints usually start out as what type of joint? I can't see y'all until team 3 has answered wrong.
Come on.
Oh.
They're like, just take one for the team. No, don't do it. Try.
Fibrosis.
No. Open back. Round 3. Fight.
Oh my gosh.
Darn drawing conclusions from the notes we read.
So it's a type of joint.
Can you re-ask the
elaborate?
question?
Can you elaborate on type of joint? Like,
That's what I'm asking. Most of your synostosis joints usually start out as this type of joint.
so when you say this type of joint, are you saying
You said synostosis?
You see all up in the back? Then you ducked, and then you confused me. I see you, but 4 kind of engaged, and now they're avoiding my eye contact. Were y'all up?
I think I already said it, but a fused joint?
No, that's the process of.
cartilaginous?
There's a lot of those. You gotta be specific.
Fibrosis?
Oy vey, everybody. Ouch.
Can you give like another example? I don't know, we're not understanding. No, you're good.
Most of your synostosis joints start off as a synchondrosis. So when we look at our long bones, the diaphysis and the epiphysis are separated by hyaline cartilage that is still ossifying. So bone, hyaline, bone, that's a synchondrotic joint. So every single epiphyseal plate, growth plate, counts as a synchondrotic joint. So 2 times however many long bones you have. Once they fuse, when you've stopped growing, each one of those cartilages has been completely ossified. And now, instead of being a synchondrotic joint, it is now a synostosis.
Did you just give us the answer?
Yes. And then I explained it.
Yes.
Thank you.
Maybe.
Can you say it one more time?
All right. So again, when you look at cartilaginous joints, synchondrosis, which is your first type of cartilaginous joints, as examples, it has epiphyseal plates, the growth plates, because you're growing. Now, once you stop growing, it's because it's completely fused together. So it stops being called a synchondrosis because there's no more hyaline cartilage. It is now fused, went through bony fusion, called synostosis now. So they changed it.
That name was called
Epiphyseal plate.
epiphyseal plate is the type of joint?
That is the specific, but synchondrosis is the type I was looking for because it's a hyaline cartilage joint.
Okay. Epi one more time.
Epiphyseal plate, growth plates.
Growth plate.
I know it's a test 2 word. And again, when you look under synostosis, your example is metatopic suture, but there's only one of those. And then it has epiphyseal lines. So you got 2 per every long bone of those guys. So a lot of long bones, a lot of those joints. Cool. Well, that was an adventure. Red. If you were going to hitch a ride, you would most likely use this body part. If you're hitching a ride properly. I know, but they were slightly faster.
The pollux?
The pollux. You're going to use your thumb to hitch a ride. Hopefully not your femur or anything else.
Dang it, plant.
One.
Yes, one.
Yay, now we got 2.
Yes. Don't really try to hitch a ride. It's not safe. People. Yes. No, that is one of my favorite commercials. Do y'all remember that beer commercial where they're driving in the dark and they see a hitchhiker with an axe? And he's like, I think we'll pick up that guy. And his passenger's like, what? So the next scene, the guy with the axe is in the back seat and they're still driving. And there's a guy with a chainsaw. They're like, I'm going to pick up this guy. And the guy with the axe is like, what? Don't. Okay, but yeah, pollux, your thumb. Hitchhiker. Good job. Purple. The liver converts lactic acid into glucose via what?
Shoot, and I know this. I just forgot.
The liver converts lactic acid into glucose via what?
Well, she's in the restroom. Can I answer for her?
Okay, you can be here.
Is it the
Think about it.
via the?
Think about it.
Okay.
Now he's stalling.
I'm gonna redact my answer.
Thank you. Can you repeat that?
All right, so the liver converts lactic acid into glucose via. Write it down.
What is that stuff called? What is that? It's sugar. Hold on. I know what is that?
There you go. The liver converts lactic acid into. Can you repeat the question?
The liver converts lactic acid into glucose via whose motor?
We have it.
Okay,
Right
here
here.
we go.
Number 1. Group number 1.
It already swooped. All right. Liver converts lactic acid into glucose via the Cori cycle. Cori cycle. Spelled funny in case you want to have a new way to spell your kid's name so you can never find their name on a keychain.
She said it. I don't think anyone got it.
No, two people.
Oh, what is it?
We were writing it down. She's like, yeah. You stepped in gum. Yuck. You turn your foot immediately to pick it off. What did you just do? Inversion. Turning it immediately. Purple. The boundary between sarcomeres would be the boundary between sarcomeres. The Z line, right? Z line to Z line is the sarcomere. It's almost like it was question 1 on the back on practical. Green. When a muscle remains the same length, but the tension increases, what is that called?
Isometric contraction.
Isometric contraction. We get tension, but we don't get any movement. Red. This is a painful contraction caused by electrolyte imbalances. Yay, we all remember 45 minutes ago. Write it on a piece of paper.
What do you mean? Write it on a piece of paper right now?
Yeah. I don't expect you to try to speak in unison, so by writing it on a piece of paper, most people can answer.
Oh.
Everybody remembers spasms. Purple.
Oh my God.
A neuron plus all the muscle fibers it stimulates is known as what? A motor unit. Kind of like an army unit. Green. Green. While trying to find a parking spot, you find a skeleton, and you thought you waited a while to find one up close. You look closer and notice that the skull has a sloping forehead, large teeth, and a fused styloid process to the temporal bone. Other characteristics include a fused sacrum that has a pronounced curvature, a pubic angle of less than 90 degrees, an unfused xiphoid process, and an A&P lab book. What can you tell me about your lost comrade?
Right here.
All right, write it down. Let's see.
The sacrum's only fused. Oh my God.
Okay, so adult is 18 to death. So you gotta narrow it down just a little.
Here you go.
Something, Mario.
Oh, I just couldn't see what you wrote. I'm like, oh, like you had purpose, and then you're like, that's it. I guess it's gonna owe today.
Okay, I got it. What is this?
Watch some fast.
Okay, is it 30?
You guys is so crazy.
No. No, exactly.
Okay.
Oh, okay.
Young male. Okay.
A young man, okay.
So we had sloping forehead, male. large teeth, male. Fused styloid process include fused sacrum, 26. So he's older than 26. Has a pronounced curvature, dude. Pubic angle less than 90, still a dude. Unfused xiphoid process, that happens at 40. So he's between 26 and 40. So we're going to call that young.
Young. Okay.
Okay. So again, there's the table that's in the handouts that gives you the specifics of this fuses at this point in time. And of course, as we went through the notes, some of it is in the axial chapter with the sacrum and the xiphoid process and stuff. So you should be able to combine all that information and give me approximates. I'm not going to ask you, is this person 25 or 15? That's above your pay grade. So when you grow up, and if you want to be a forensic scientist, you would know that. But at this point, we're just going to go with young or old. Okay? Under 40 is young, over 40 is old, but we don't feel it. Okay? This looks stuck. All right. Red. This is an autoimmune disease that attacks the neuromuscular junction. Myasthenia gravis. Myomuscle, sleepy, gravis, disturbing, in a hurry. You know. What is the strongest functional class of joints? Look, everyone half-massed that one. Write it down. Write this down. I feel very much like Dan Wilder.
You said the strongest, right?
I did.
Okay, we got our.
I heard your answer. You were right.
Oh.
I gotta commit. Oh, diagnose for everybody.
Yes.
All right, synarthrosis. If you don't move, you can't dislocate. Makes it pretty strong. Yellow. When the vertebral column bends to the side, what is that called? No. I know, everyone else thinks that too.
Lateral flex.
Lateral flexion. We don't have a bad curvature, we're opting to bend to the side. Green. This covers a fascicle. Perimysium. That was a quiz question back then. Perimysium covers a fascicle. Herbal. This muscle exhibits automaticity. This muscle exhibits automaticity.
So that word.
Muscle.
Muscle.
No. Cardiac muscle. Automaticity can beat on its own, contract without neural stimulation. So your heart can keep beating.
Is it automuscicity or muscicity?
Ma. I just don't enunciate all my words properly. Automaticity or autorhythmicity. They're both accepted. Red. When does the patella finish ossification? Write it down.
Write it down.
Your hand is not. I know, I'm coming. I'm just slow. Ends.
One.
All right. The patella finish ossifies ossifying at the end of puberty, right? That's why we have so many knee injuries in high school sports, because it's solid now, so the ligaments have to take the hit. Starting is when you walk. You know, what bone stands on its head?
Right here.
If you don't know by now, okay, write it down. Oh, I'm coming. I mean, energy saving movement. You're just throwing stuff out. Giant green toast.
It's so tiny.
Tell me about it. All right, the ulna is the only bone that stands on its head. It's going to be like the mitochondria, the one thing you remember from A&P, mitochondria powerhouse. It's the ulna stands on its head. Purple. Your teeth are held in the maxilla by.
Right here.
Wait to see you twitch first. Gomphoses. I know. Good old question. What was that? 3?
1. We're 1.
I mean, on your practical.
One
Oh.
of them. Something.
Yes. The question is 2 or 3. Green. Contraction of this group of muscle will cause an organ to elongate. Contraction of this group of muscles would cause an organ to elongate.
Smooth muscle. Circular layer.
You know, the circular layer of your smooth muscle. 2.
Yes.
So the circular layer elongates the organ, longitudinal shortens, so we can have that squeezing. Red. A hinge joint that allows for flexion and extension only would have this type of movement. A hinge joint that allows for flexion and extension only would have this type of movement.
Right here.
No,
Door hinge. Hinge.
no. Oh, Team 4's like, and I'm out. Shh, don't look at me.
Okay, one more time.
Well, I can't one more time. Because we got 2 people. No. Hinge joints that allow for flexion and extension only would have this type of movement.
Hold on. Go down. Movements right here.
I know, but Team 4 hasn't answered yet, so I can't see you until Team 4 finishes.
Yeah.
Hinge joint that allows.
You're just nodding at me.
Yeah. Increasing and decreasing of the angle of a joint.
No. Open back.
Can you re-say it again?
Yeah.
A hinge joint that allows for flexion and extension only would have this type of movement.
Okay, right here. The monaxial movement.
Monaxial. Right? Movement in one plane. So flexion extension is only in one plane. Again, if you have 2 planes, that's going to be biaxial, and if you can rotate it all the way around, it would be triaxial. Got to remember our 3 dimensions, and that Borel graph we often have to do in math class, right? Remember math? The X, the Y. X, Y, Z. Okay, so flexion and extension would just be on the X or the Y. Depends on which one you're looking at.
Oh, my goodness.
Curse you math class and your ability to apply to other side. Green. When a muscle runs out of ATP and the myosin cross bridges are unable to detach, what type of contraction is that? Are you committing?
Wait. No,
Okay.
I'll do that. What type of movement is it?
When a muscle runs out of ATP and myosin cross bridges are unable to detach, what type of contraction is that? Contraction. You're stuck. Can't move anymore. Contraction. Purple. This ligament is found inside of a joint capsule. This ligament is found on the inside of a joint capsule.
So is that ligament found inside the acetabulum? Connecting to the hinge?
It could be that it's one example of these guys,
Okay.
but not the only
Oh, it's
example.
right here.
Oh, yeah.
No,
It's this.
we're not going specifics. We're just what kind of accessory we're looking at.
No. Yes. ligament.
Ligament found on the inside of a joint capsule.
Right here.
Intracapsular. So inside of the joint capsule. Huh? So that would be like the anterior cruciate ligament, posterior cruciate ligament. They're inside of the knee. So they would be our intracapsular ligament. The collaterals would be accessory ligaments. They're really big on the side. Red. What is released by the synaptic end bulb?
Neurotransmitters.
Known as
Vesicles.
neurotransmitters, a wide category of chemicals that are made by the neurons. What one did you want to use?
Acetylcholine.
Okay. Acetylcholine. So that's what's going to tell our muscles when to contract. We'll get introduced to a lot more neurotransmitters this week. Ooh, it's exciting or something. All right, so acetylcholine is released released by the synaptic end bulb. Yellow. With a herniated disc, the outer layer will rupture, releasing the inner layer. What is the outer layer called? With a herniated disc, the outer layer ruptures to release the inner layer. What do you call the outer layer?
Okay.
Oh, sorry. This, Pulverus, rust.
Bless you, but no.
Okay.
Outer layer.
What was the question?
With a herniated disc, the outer layer ruptures, releasing the inner layer. What is the outer layer called?
The annulus fibrosus.
The annulus fibrosus. Fibrosis because it's fibrocartilage, annulus because it's around, like annuals once a year. You gave me the squishy inside. Red. What do myoblasts do?
They,
Well, hello, there. Write it down.
they,
Myoblasts. What do they do?
right here.
I'm coming. going? Jeez, I'm slow.
Wait, the answer more specific.
Yes. She said, okay, that's okay.
I don't know what that says.
Build muscles.
A lot of things. What are y'all committed to? I love the interpretation.
I got them mixed up.
Mm-hmm.
I don't even know.
Myoblast, myomuscle blast build. They build muscles.
I was thinking I was right. No, you put I said this one.
All right, so myoblasts are going to build muscle cells. They also become satellite cells when they retire, or they become the nucleus of a muscle cell when they are done building. So they do a lot of fun stuff. Aren't you glad this is not a fill in the blank test? Me too. It would take freaking forever to do anything if it was all green. This bone originates at the manubrium.
This sternum.
No. I love Giovanna. Clavicle. Clavicle comes from the manubrium to the acromion of the scapula. The scapula then hooks to the humerus. Connects to the manubrium.
You said it originates?
That's its sternal end. And the other side is the acromion. Trust me, I know these things. Purple. What hormone relaxes the pubic symphysis? Write it down.
I got it.
I know we're writing. Oh, you're talking to you. I'm like, you guys have a higher opinion of my ability to get.
Did you see it?
Not yet. She hasn't started.
You wrote it already.
This is walking fast.
I'll come back.
Well.
With that.
What hormone relaxes the pubic? This relaxes the pubic symphysis, a hormone called relaxin. That's how it got its name. It says, relax, let the kid out. Yellow. A quick, jerky contraction in response to a single stimulus is known as what?
Twitch contraction.
A twitch.
Yeah.
Purple. Spreading your fingers is what type of movement? Can you tell me what the second letter of your word was?
Abduction.
I had to make sure I could hear you. E2.
You said up or ab?
Ab.
Oh, yeah.
So spreading is abduction, like aliens would abduct you by taking you away. Adduction would bring you back in.
Abduction.
You know. What is the basic contractile unit of skeletal muscle called? Sarcomere. That's your horse in horsepower. Sarcomere. Green. Exercise will increase or change the function of these cells. Exercise will increase or change the function of these cells.
Restricted self of oxygen.
Instead of which cells?
Yes. Exercise will increase or change the function of which cells?
I don't know.
Would it be slow and fast fiber?
No, you just gave me two different types of cells.
Oh.
But no.
Wait.
Intermediate fiber.
Intermediate fibers. So if you want to have big, ripply muscles like Arnold, you go to the gym, you lift weights, you do powerful, strong weights that you don't run around the gym with, and that makes your intermediate fibers look more like fast fibers, so they get bigger and you get ripped. If you want to run marathons, you train, and those intermediate fibers start to look and act more like slow fibers, so they're going to get smaller but have better endurance. So the intermediates are what you change when you go to the gym, or you decide to do ballet, or you decide to do yoga. You have those intermediates can change functions or characteristics between slow and fast. Fast and slow fibers are genetically determined, so you can't change or get any more. So if you have chunky legs, you just go have chunky legs. You're never gonna have bird legs, no matter how much you run. In case you wonder about those, like how come the calves? Why? Leg issues. No matter how many times people go to the gym, sometimes they just have stick legs. Not just because they skip leg day. Because they got their muscles that way. Red.
Mhm.
What are the weakest parts of the skeleton? Joints. Where the mobility is. Right? We are more likely to dislocate something or sprain something. Here's you first line in the joint chapter. Yellow. Marathon runners would use this type of energy to fuel their activity.
Mechanism.
That's okay. I often sometimes say mechanism. It's because of mechanics versus mechanism. It's just not right.
What was that name? Anaerobic?
Aerobic.
Aerobic.
So marathon, you need lots of oxygen. You need to breathe a whole bunch. Aerobic. If you're going to do leg squats or the gym, you're going to use direct phosphorylation. If you're just going to do something like tennis, anaerobic metabolism. Red. The functional classification of the knee would be what? The functional classification of the knee.
Diaphragmatic.
There you go, diarthrotic. It's a diarthrotic joint. Green. During class, you hyperextend your cervical vertebrae. What happens next?
Say that again?
During class, you accidentally hyperextend your cervical vertebrae. What happens next?
You break your back.
No.
Dang it. You extend.
Your cervical vertebrae.
Oh, dang it, I know this. I know this. Cervical.
Dislocation? Dislocation?
No.
Flexation.
No.
Can you reread it?
During class, you hyperextend your cervical vertebrae. What happens next?
Oh, it's this.
What you doing when you hyperextend your cervical
Can I
vertebrae?
answer?
Milk Tinkle hasn't jumped in the pool yet.
Please.
Very cautious.
No.
I still haven't said anything. Hyperextended your cervical vertebrae.
No.
What happens?
Are you gonna kill?
I am recording. Oh, I'm not recording.
Spring?
Huh?
Spring.
No.
Okay, we have it.
Looking up at the ceiling.
You're looking at the ceiling. Nothing happens. It doesn't hurt you. So you didn't break anything. You didn't damage anything. Just looking up at the ceiling. I know it sounds impressive. One, right?
Yes.
So the only part of your spinal vertebrae to hyperextend is your cervix.
Cervical for most people without pain. Now, it depends on other people. They could also do it to their lumbar if they're flexible, and if they're super flexible, not me, thoracic. But for most of us, it's just the cervical that we can do it to without problems. All right, good game, people. Team 4, they hate you, just saying. Gotta need your name on a piece of paper. Everybody else got the benefit of knowledge. You learned something.
You'll
Please
win
return my
some
sticks.
and you'll lose some.
But we feel better than we did an hour ago.